Okay, finally, problem 11 also appears to have been a problem that caught some of your eye. Here you're talking about the number of people that get into a line in a 15-minute chunk. Okay, we should be able to realize that that can be modeled with a probability distribution. And although you're not specifically told what the success rate is, if you know the formula of the Poisson PDF, then you can see that anywhere that there, in my case, was a 17.9 happens to be the letter lambda. So here the success rate for me must be 17.9 patients, or people, I guess, per 15 minutes. So here I've got lambda being people per 15 minutes. And x, which is a discrete distribution called Poisson, is counting the number of people that maybe could have come in particular 15-minute chunks. So if you imagine looking at a line for 15 minutes and counting how many people come into that line in those 15 minutes, you can think about what options could have been possible. Perhaps you view the line for 15 minutes and 0 people show up. Or maybe 1, 2, 3, 4, maybe all the way up to 20 people show up, or even higher. The first question then is asking what this lambda really represents. Okay, so remember, here, how would we find this number, which happens to be 17.9 people, in my case, that typically show up in 15 minutes? Would you find that number by simply just taking all of these options, 1, 2, 3, 4, 5, 6, 7, all the way up to infinity? Would you add all those numbers up and divide by how many numbers they are? That's what's called the arithmetic average, or the way that people typically think of an average, where they just take the numbers that are possible and add them up, assuming that each number is just as likely as every other number. If you think that that is the correct answer, then you should just simply be saying it's the average number of people. However, if you realize that these may in fact be the options that are truly possible, however not each option is as equally likely as every other option, then instead of the kind of average or the expected value that you would be calculating is each option multiplied by its particular probability, or in other words, each option multiplied by the weight of how likely that option is to occur, which of course gets you to a different kind of average, which is called the weighted average, much more like how you calculate your final grades in courses, where you say, I have to take how well I've scored on any particular grade component and multiply it by how much that grade component is worth, not just simply taking the simple arithmetic average of every score that you've accumulated in the course. We then get to part B, which is saying if you are going to use this probability distribution model, what's the chance that 18, or exactly 18, people show up in the lineup after 15 minutes? In this case, you can just use, because we're using the equal sign, the D command. This is the command that you can use in R. So here I use D, not P and not Q, but D of the distribution name, which is Poisson. And in this case, I'd say D Poisson of 18, and then I would state whatever my lambda appears to be. If I'm looking for the probability of at least some number of people, then of course I am looking for the sign that is the greater than sign. We've seen in past questions that you can do the less than or equal to sign by using the P command, and you can also use the D command to talk about the equal sign itself. I don't have a sign to tell you, a command to tell you about the greater than sign, so instead I will think of trying to find the probability of having at least 5 successes by instead focusing on 1 minus at most 4 successes. So I should be really careful in how I map this out. Maybe I could draw it out. I've got 0, 1, 2, 3, all the way up to 4, then 5, 6, 7, 8. And in this case, I want greater than or equal to 5. And if I want the complement of that particular probability, it would have to be 1 minus less than or equal to 4. There are a few ways that I can think to calculate this area here. One is by using the D command and individually finding the probability of x being exactly 1, or exactly 2, or exactly 3, or exactly 0. Sorry, I missed that one. But here I could say D Poisson of every value in between 0 and, in this case, 5 minus 1, which would be 4 in my case, and then then adding up what those probabilities are. If you do not want to individually find out what each of those probabilities are separately and then add them, you can simply use the p command, which really is the less than or equal to sign, to say this is 1 minus cumulative, or p Poisson, of 4, where lambda is, in this case, 17.9. So both of these should give you the same answer. One of them is saying, please find me the exact probabilities at the values 0, 1, 2, 3, and 4, and then add them up. And the other is just saying, find me the probability of being less than or equal to 4. Finally, at the end here, you have another conditional statement that is given to you. So here it's saying, perhaps we know that the value is in between 14 and 12, or here between letters A and C. And what is the probability that, given we know it's between those values, it happens to be one of the numbers that happens to be between those values? So here, say, what's the probability it's actually B, given I know it's in between A and C? Again, we can write the intersection of these two statements by saying x is equal to B and x is in between A and C, divided by here the probability of the condition. When we know that the value is actually B and the value is in between A and C, there is only one place where these two statements intersect. So they can only be true where x is actually equal to B, for it to be equal to B, and for it to be in between A and C. And then we can finally find the probability of being in between A and C down here as shown. So what I would try and do then, finding the numerator, is that probability of x is actually B, which happens to be 15 in my case, so that would be d Poisson, because I've got the equal sign, of 15, where the success rate is as given. And then I need, in the denominator, to find the probabilities of x being, in my case, 14, 15, 16, 17, 18, 19, or 20. I can do this by finding all of these individual probabilities by saying this is d Poisson, where I start with 14, and then I say colon 20. That will tell the computer to find the probabilities of every value in between 14 and 20 inclusive. And then I will simply add them all up by using the sum command, and I've got what I'm looking for there.